scientific method. There are specific steps that scientists follow when they investigate a phenomena, and these steps are called the scientific method. The scientific method consists of 4 steps, and they are: 1. Making observations and collect data that lead to a question. 2. Formulate and objectively test hypotheses by experiment. 3. Interpret results and revise the hypothesis if necessary. 4. State conclusions in a form that can be evaluated by others. In this video, we will explain these steps using Galileo's thought experiment. Galileo thought about falling objects, and he developed a hypothesis about how objects fell. Then, he modeled the behavior of falling objects in order to test his hypothesis. A hypothesis is a reasonable explanation for observation, and can be tested with additional experiments. The first step in scientific method is the observation. Galileo thought about objects with different masses falling at different rates. He imagined 2 bricks of different masses. Then he put 3 possibilities for the falling objects. First, if the 2 bricks release from same height at same time, then the heavier brick will reach ground first because it has more mass. Second, if the 2 bricks tied together and release at the same time, from the same height, therefore, the heavier brick will speed up the fall of the lighter brick, and the lighter brick will slow the fall of the heavier brick. Then, the tied brick should fall at rate in between that of either brick alone. Third, as the 2 bricks together have greater mass than heavier brick alone, therefore, the tied brick should fall faster than the heavier brick. Step 2. Formulate and objectively test hypotheses. Galileo used the logical contradiction to refuse the idea that different masses falls at different rates, and he produced a hypothesis that all objects fall at the same rate in the absence of air resistance. Testing hypothesis by experiment. Galileo modeled the behavior of falling objects in order to test his hypothesis about how objects fall. He performed many experiments to test his hypothesis by observing differences due to weight, and he kept all other variables the same, as size and shape. He used balls with same sizes and shapes but with different masses. He used a ball rolling down a ramp as a model of the motion of falling ball. The steeper the ramp, the closer the model came to representing a falling object. The conclusion. The ramp experiments provided data that has matched with Galileo's prediction in his hypothesis. The experiment proved the correction of his hypothesis. Controlled experiment. When testing hypothesis, we just make one change to one variable at a time to determine what influenced the phenomena that you are observing. After scientists get the results of the experiments which may support their model, another experiment may produce results that don't support their model. If this happens, scientists repeat the experiment until they are sure that the results do not contain errors. If the unexpected results are confirmed, then the model must be abandoned or revised. A conclusion is valid only if it can be verified by other people.